Okay, good morning all of you. So in today's session of class 10 chemistry, we are going to do acids, bases, and salts. Now in this session, what we will do is we will look at uh, some acids and some bases, and with the understanding that uh, why these are called acids and bases. Okay, now this is a chapter in which there are certain terms which will have multiple definitions. So there are a few ways of defining an acid, there are a few ways of defining a base. So in today's session we will concentrate on the most basic definition of acid and the most basic definition of base. The most basic definition of acid is that in aqueous solution, like if you put that substance in aqueous solution, then it will release hydrogen ions, right? It will release hydrogen ions. And the most basic definition of a base is that if you put that substance in aqueous solution, then it will release hydroxyl ions, OH minus ions. So this is the most basic definition. But there are other ways of defining an acid and base, and we will of course talk about them as we progress in our sessions. So in today's session I have written the names of a few acids on the left side. This is HCl, it is called hydrochloric acid. This is H2SO4, it is called sulfuric acid. HNO3 is nitric acid. CH3COOH, it is called acetic acid. Acetic acid is also known as vinegar, right? It is acetic acid, but it is also known as vinegar. Then you have COOH whole twice. This is called oxalic acid, and oxalic acid is typically found in tomatoes. Oxalic acid. And then you have H2CO3. So this is called carbonic acid. Like you have heard of soft drinks having a certain amount of fizz. When you open the soft drink bottle, there is a fizz. So that fizz is because of dissolved carbon dioxide. So under high pressure, the soft drink bottle is sealed. So because of the high pressure, carbon dioxide dissolves inside the soft drink, and when carbon dioxide goes into solution, you get carbonic acid. So that is H2CO3. So these are the 6 acids on the left. On the right you have 1, 2, 3, 4, 5, 6 bases. Okay, this is sodium hydroxide, this is potassium hydroxide, and this is ammonium hydroxide. Now the thing is that we will learn more and more about acids and bases as we continue with our session. But sodium hydroxide, potassium hydroxide, ammonium hydroxide, they are also called alkalis. Okay, they are also called alkalis because they are soluble in water. I will be telling you about alkalis later. So this is a base: sodium hydroxide, potassium hydroxide, calcium hydroxide, copper hydroxide, ammonium hydroxide, and aluminium hydroxide. So these are all bases, these are all acids. Now in today's session, I told you that this is a chapter which is going to continue for some time. So in today's session, I will just give you one example why this is considered an acid, and I'll give you one example why this is considered a base. And with the help of that example, you will have to write the reactions for the remaining 5 acids and the remaining 5 bases. Okay, I'll give you one example of each, and the rest you'll have to do for a homework. So I'll just give you one example of each. So let's say, for example, you are talking about HCl. Okay, let's say you are talking about HCl. So if you dissolve HCl in solution, actually you have to remember one thing, all of you, that these substances, they are all called acids and bases after the original substance has been put in solution, that means put in water. Now all of them are not solids, some of them are gases, like hydrogen chloride is a gas. So if you put hydrogen chloride gas in water, you will get hydrochloric acid. So HCl is a gas. If you put it in water, you will get HCl acid, and that is H plus and Cl minus. So when you put HCl in water, it will split into the ions H plus and Cl minus. So that means it will supply H plus. So any substance which in aqueous solution releases H plus is an acid. Now this is a definition of acid which never fails, right? It never fails. If a substance gives H plus ion in solution, it has to be an acid. This definition doesn't fail, but there are some other definitions which we will look at in the other session. But this definition is a fixed thing. It will never fail. So if you put hydrogen chloride gas in water, you will get hydrochloric acid, and hydrochloric acid will release, like as soon as you put hydrogen chloride gas in water, you will get hydrochloric acid, but in that medium you will have H plus and Cl minus ions. In fact, later on you will see that this is the reason why acids and bases are reactive, because of the ions which they produce in solution. So HCl will produce H plus and Cl minus, and it is due to the H plus, it is considered an acid. Okay. Now coming to the base column. So in the base column, I am just showing you AlOH whole thrice. Okay, I am just showing you AlOH whole thrice. So AlOH whole thrice, I am writing in solution. It will give 3 OH minus ions, and it will give 1 Al3 plus cation. So that means that to understand what will happen when you put these things in solution, you must be very good in your understanding of radicals. Radicals you have done in class 9. You have a good idea about all the types of radicals. So you know that OH radical has got -1 charge, but aluminium has a valency of 3. So aluminium ion will have +3. So in solution you will get Al3 plus and 3 OH minus. So in every sense this is a balanced reaction. The charges are also balanced. Okay, this is a reaction which is self-explanatory. The important thing is that aluminium hydroxide is releasing OH minus ions. It is called hydroxyl ion. So that is why it is called a base. Now this definition never fails. If somebody produces OH minus ion, it will be a base. So aluminium hydroxide is a base. Now you will notice one thing, that in case of HCl, I gave a single arrow, but in aluminium hydroxide, I gave a double arrow, right? Now the thing is that HCl is a strong acid. It's a strong acid. If you take hydrogen chloride gas and put it in water, it will fully split into H plus and Cl minus, fully. So it is a strong acid. Aluminium hydroxide is not a strong base. So that's why we put a double arrow. Double arrow means that a stage will come when you will have some ions, but you will have some undissociated aluminium hydroxide, and they both will stay together in the solution. That's why there is a double arrow. Like it is this way as well as that way. So there is a double arrow. It's called reversible reaction. Now there is a rule. If you are not sure whether reaction is reversible, that means you are not sure whether this is a weak acid or a weak base. If you are not sure, then you can put a double arrow. That is better. So there's nothing wrong in putting a double arrow. So you can put a double arrow for HCl also, right? There's nothing wrong. If you put a double arrow, there's nothing wrong. I'll tell you why. You see, double arrow means the reaction can go this way and that way both. But when I am asked to give a mathematical calculation, I will say that by the time the reaction is over, there is no HCl. It's fully H plus and Cl minus. So that means I can put a double arrow, but I can mathematically justify it by saying that at the end of the reaction, this quantity becomes 0. And these two quantities are the only quantities which are there in the solution. So mathematically I can justify it. And here, when I am explaining it mathematically, I'll say that when the reaction reaches an end, that time I have certain amount of these two, but I have some amount of this also. So I can mathematically justify it if I always give a double arrow. So some book writers suggest that to be on the safe side, it's always good to give a double arrow. By the way, just for your information, like sodium hydroxide, potassium hydroxide, calcium hydroxide, they are strong. Okay. Sodium and potassium hydroxide are very strong. They are called caustic bases. Okay, they are called caustic bases, and the thing is that acids are generally sour, bases are generally bitter. That is how we distinguish taste wise. But you understand NaOH and KOH, they are caustic. Okay, so that is why this is called caustic soda, this is called caustic potash. So caustic means they can cause abrasiveness, they can cause some scraping and some friction. So that is why they are called caustic. Okay, and this is also a strong base. This is a weak base, this is a weak base, this is a weak base. So over here, this is strong, and these three are weak. So the top three are strong, bottom three are weak. Top three are strong, bottom three are weak. But if you are not sure whether it is strong or weak, it is always better to give a double arrow. Okay, no teacher will object if you give a double arrow, because I told you can justify it mathematically. So this is today's session. What you have to do, your homework is, I have done one of the acid and one of the base. The remaining 5 of the acid and the remaining 5 of the base, you will have to put a double arrow and complete the reaction. So I am concluding the session for today, and we will continue the next session, acid basis salt. Thank you. Bye all of you.